Hello.
Okay, so Piyush, so start with your brief introduction, please.
Good afternoon, sir. My
Okay,
name is Piyush Singh, currently pursuing BTech in Electronics and Communication Engineering from Netaji
okay,
Subhash University of Technology, Delhi. And my research interest here is low power electronics in the field of VLSI, sir.
okay. What do you understand by low power electronics? First of all, define it.
Low power electronics, basically anything which involves the power dissipation is very in the order of millivolts, something like that.
Okay, okay. So you can start with your PPT, please. Go ahead.
So is it visible?
Yeah, it's visible to me.
Yeah. So here I have applied for interview in microelectronics and VLSI,
Okay,
completed my and pursuing my Bachelor of Technology in from NSUT East Campus. And coming to my research interest, as I told you, my research interest is low power electronics, and why it is important. It can be understood with the help of these two curves. The first one is very important, Moore's law, which
okay,
states which became the universal predictor for the growth
mm-hmm.
of semiconductor industry.
Okay,
As we know that by Moore's law, the devices on the chip doubles almost every 18 months.
okay.
So power consumption, if it is very low, still if devices are growing with such a huge rate, still the power factor will be very important and significant terms. Earlier we used to consider only two parameters, namely area and performance. But as of now, we can't underestimate or underestimate the power
About
term.
about which power factor you are talking? Tell me.
So power dissipation, sir, basically.
Okay, you are talking about the low power electronics. Okay,
Yeah, yeah.
okay. Have you heard about some MOSFET scaling?
MOSFET scaling, yes, sir, I have heard.
Tell me what is the effect of MOSFET scaling on power? Can you explain?
MOSFET scaling on the effects of power.
Hmm.
So increasing the MOSFETs number count will increase the power consumption or dissipation.
What is MOSFET scaling? First, explain the term MOSFET scaling.
MOSFET scaling, sir, right now, I think.
Any idea?
Sir, I have heard this term, but not able to recall it. Yes, sir, I
Hello.
am unable to answer this question.
Okay, you're not able to answer this question.
Yeah,
Okay,
yeah,
fine, no issue. What is difference between static and dynamic power dissipation?
yeah. Basically, the major role in power dissipations come from dynamic one. But what is static? That if the input is constant or fixed, that and the contribution in the total power term from this fixed input is calculated under the static power dissipation. Whereas if input is in the phase of transition or it's constantly changing, then we define it as dynamic power dissipation.
Okay, have you studied MOSFET?
Yes, sir.
What are the different sources of power dissipation in CMOS?
Yeah.
Any idea?
Yes, sir. Yes, sir. And the
Okay,
power,
explain me.
sir, I have to explain the different sources of power dissipation or
Yeah,
power dissipation.
my question is what is the sources of power dissipation? Okay, according to you, you can explain your viewpoint.
Yeah, I think if the main source of power dissipation in the MOSFET is, sir, that load capacitance. The
Hmm.
charging and discharging of the capacitor is very much significant in power dissipation.
Okay. So have you heard about this sub-threshold leakage?
Sub-threshold leakage, yes, sir, I have heard.
What is difference between sub-threshold leakage and gate leakage through gate dielectric?
So sub-threshold leakage and
Gate leakage through gate dielectric.
So sub threshold leakage, basically it means that if the applied potential is for
Hmm.
conduction of current in the MOSFET, we need some over sub potential which crosses its threshold barrier. But
Hmm.
as we are increasing the drain VDS or drain to source voltage, the voltage will decrease at the VDS will decrease at the, I think,
I don't
drain.
think so, Piyush. You are well
Yeah,
confirmed with this. Hmm?
yeah, I am a bit in confusion, sir.
Okay, now tell me what you understand by the active power and standby power.
Active power means when device is under operation,
Okay,
and during the time of operation or it is performing some calculations, the
okay,
power consumed during this interval is we called as active power.
okay. Now,
Whereas
what is this standby power?
standby power is that device is in under on condition but does not performing any calculations or any mathematical operation, it is performing standing idle, something like that.
Okay, being a designer, suppose you
Yeah.
are a IC designer. What are the different region you should look into improve?
So we, so from viewpoint of MOSFETs or general IC point?
General, general integrated circuit.
Yeah. So we should look on the power consumption, its
Hmm.
as size, dimensions,
Hmm.
and aspect ratio basically for it come under the size only. And
Okay, suppose hello.
yes, sir, optimization area
Suppose
wise.
I'm giving a your CMOS inverter is operating at a 200 megahertz
Okay, sir.
and your power supply is 2 volt
Yes, sir.
and your load capacitance is 10 femtofarad.
L- Load capacity 10 femto. Okay, sir.
Mhm.
Yes,
Now,
sir.
can you tell me what will be the average dynamic power dissipated?
Yes, sir.
Yeah, tell me.
You told frequency as 200 mega, na?
Yes.
So I need time to calculate this.
Sure.
So it, so I have one doubt that if femto means 10 to the power minus 15, na?
Right, right, right.
Yeah. So it will be 8 into 10 to the 8 into 10 to the power minus 5 watts, sir.
Okay, if I double the aspect ratio of the transistor, W by
Uh,
L, then what will
no,
be
no,
effect on this dynamic power
no
dissipation?
effect on the power dissipation, sir.
Okay, now explain what do you mean by the power dissipation due to short circuit current in case of the
Source
CMOS inverters.
power dissipation due to
Short
short.
circuit current.
Basically what happens under this short circuit power dissipation when we are changing the input, but for the moment we get the connection across the voltage rail from VDD to ground, which is the reason which is the reason of current flowing, and as
Why,
current,
why,
yeah.
why this happen?
So this happens for a very short interval of time
No,
because,
that is fine, but
yeah,
why it happens? That is what I'm asking.
this happens because NMOS and PMOS both operate, sir, as it is changing from when the input is
But
changing
when
from,
we are using it in the inverter, then they operate in the complementary fashion. One is on, one is
yeah,
off. Then
yeah. But as it is under the effect of transition, sir, for NMOS to work we require high value, high potential, or as compared to, and for PMOS to work it requires low potential. So during the time of in transition we have both the conditions.
पीयूष अब आप गेस करने लग गए हो. आर यू श्योर अबाउट दिस एक्सप्लेनेशन जो आप बोल रहे हो?
Yes, sir.
आई डोंट थिंक सो. Okay, fine. Tell me what is the how you mathematically calculate the short circuit power dissipation?
So mathematically, I think power short circuit power dissipation is proportional to the VDD minus. Sir, I am not able to remember this. I have studied. It's we inversely it is the it follows the quadratic relation of some VDD minus 2 by 3 VT.
Okay, go ahead with your PPT.
Yes, sir. And this we need for this. Sir, do I need to explain these terms or?
No, 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 no. That is fine. You can switch
uh,
further. Please go ahead.
Yeah. So they asked me to what will be your tentative objective and methodology.
Okay,
So as we know that there are mainly three reasons in
okay,
CMOS for power dissipation. One is,
okay. Wait a
yeah,
minute. There you
yeah,
have drawn some system, algorithm,
yeah, yeah, yeah,
architecture,
yeah. Yes,
logic circuit,
yeah,
device, and process, right?
yes, yes, sir.
So what do you mean by algorithm here? Define this term algorithm. How you defined?
Algorithm is, sir, what we are choosing, in which fashion we are designing the device.
Do you think this is the algorithm? Hmm?
No, sir.
Okay,
Algorithm.
go ahead. Go ahead, please.
So I am studying all these things. Yeah,
Mhm.
yeah. For the power to reduce the power consumption, so we need to optimize the circuit at all these levels. Basically, system all these, and there are various methods to reduce the power consumption or optimize the power dissipation, and we can take the help of these tools, Xilinx, Tanner. I am not very much familiar with these tools, but I will learn. And
Okay, now go ahead. Is there anything else in your PPT?
yes, my major project explanation.
Okay, what was your major project? This was about.
So my major project was about on-board flight controller of unmanned aerial vehicle or quadcopter from the control
Okay.
system perspectives.
Okay, tell me which sort of the control system you employed in this project.
Sir, I implemented the PID controller part of.
Can you tell me how to design PID controllers?
Yes, we use the
The
we
one
take.
thing in one case use the active component to design the PID controller, and in other case use the passive component to design the PID controller. And show me.
Yes, sir. So is this visible?
Okay.
So this
Do
is
you
the
think
use of active
do
component.
do you think this will work as a PID controller? Hmm?
Yes, sir. We can take the help of,
Okay.
and with the help of passive passive components, we need to implement separately, I think.
Do you have any idea how we can implement?
So I can, I'm passive components. No,
Okay,
sir.
you do one thing. Go back in your slide.
Yes, sir. So which segment?
Again, again go back. Again go back. Okay, you have no no. Come next. Okay, you have drawn here CMOS schematic. Go back. Back.
So this is the only, after that.
This one only. You have
Yes,
shown
sir.
here CMOS schematic. Okay.
Yes, sir. Yes, sir. Yes, sir.
So can you draw the this load current versus time curve for this
Load current.
versus time? Load current is the current across capacitors.
Okay. So I'm not very much sure about it, but I think it will follow exponential relationship over time interval.
How it will follow exponential relationship? Yeah, according to you, it means it will keep on only in the one state. It will switch 1 0 1 0. Do you think that it will always follow exponential? If you are saying it will go exponential, it means you are considering that your output will be at the some fixed level. Hmm?
Okay. ID. Set. No, 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 sir. No, sir.
Okay. When your interview is at IIT Roorkee, tell me.
So it is on 17. One is on 17 and other one is tomorrow, sir.
For tomorrow is for what?
So VLSI.
So on 17 it is for what?
RF.
RF means radio frequency.
Yes, sir.
Okay. See, right now, whatever PPT you have prepared,
Yes, sir.
go to first page.
Yes, sir.
The very first thing is your topic is low power electronics.
Yeah.
Okay.
Yes, sir.
So next is why power dissipation is so important, that you discussed. That is fine, you discussed. Okay,
Yes,
that
sir.
was just a general discussion
Yes,
that you
sir.
have done, right?
Yeah.
But when it comes to your domain, in which sector of electronics? Electronics is a wide domain. So
Yeah.
basically, in which sector of electronics you are talking about the low power improvement or low power technology, right? So obviously you will talk about integrated circuit. You got my point.
Yes, sir.
And in integrated circuit, they will directly go to the, what are the different type of the power dissipation, active power, standby power, those power definition point of view you told me, right? Okay.
Yes, sir.
But there are so many factors which are responsible for the power dissipation. First of all, you must have that idea what are those factors. Is
Factors
it
on which
clear?
power? Yes, sir.
I don't think you are well aware of those all factor, right? You are knowing some of the factor for sure, which are the commonly known factor. But when you are presenting them some PPT, it means, and your topic is itself the power. So
Yes,
they are
sir.
considering that you have done a, very hard or very long R&D behind this power topic. So they can expect, that you give them something best. Is it clear?
Yes. Yes, sir.
But I don't think, don't mind, I'm giving the honest review,
Yes,
okay?
sir.
But
Yes,
I
sir.
don't
Yes, sir.
think it doesn't, somewhere touched very close to that you have done some hard work. Is it clear? The
Okay,
very
sir.
first thing is what are the different sources of power dissipation? See, power dissipation CMOS circuit comes from basically two components. One is dynamic dissipation, second is
Yes,
the
sir.
static dissipation. Okay.
Yeah. Yeah.
Now the dynamic dissipation is switching plus short circuit current, which I asked
Yeah.
you.
Yeah.
Okay. So we can say the dynamic dissipation is due to the charging and discharging load capacitance as a gate switch. जैसे gate आपका switch होता है, ठीक है ना?
Yes, sir.
Gate switch means input logic switch, okay?
Hmm.
And short circuit power dissipation is the power due to current while both PMOS and NMOS are partially on. Why it happens that I discuss later on, okay?
Yeah.
Second is static power dissipation. In static power dissipation, you can discuss the sub-threshold leakage through off transistor. Usually we consider that if your VGS is less than VTN, then there is no current.
Ideally, no current, but some leakage
But
current is
practically
there.
it practically doesn't happen. Okay.
Yeah.
So you need to study about what basically this sub-threshold leakage is. Then
So
there might be also one source gate leakage through gate dielectric. Okay. There might be junction leakage from source drain diffusion. Is it clear? So these are the all sources of power basically. Fine.
sir, you told source drain diffusion.
Junction leakage from source or drain diffusion. Okay.
Leakage. Okay, sir.
Is it clear?
Yes, sir.
So this all I will share with you as a photo. Don't worry, you don't need to write it.
Okay,
And
sir.
I'm sharing also with you one of the book that you must read at least and have the idea. You can study that book. That is a very good book basically for this topic. Okay. And second thing is read about MOSFET scaling at least. What is MOSFET scaling? Okay, MOSFET scaling is basically reduction in the size of the MOS. Is it clear?
Yes,
So
sir.
how the power is affecting and how the power is affected if we scale the MOSFET. You must have basic idea about this. They can ask, right?
So MOSFET scaling means that we can try to connect with series and parallel depending upon the aspect ratio, something like that. I have not
No, no, no.
proper
That
very
is
idea.
that is something different. Okay, you're
Yeah.
saying something different. Getting?
Okay, sir. I will go through it.
I'm sending you book. You just go through that, and that will be very helpful for you. At least you get some fair amount of idea what basically happen when we scale the MOSFET. Is it clear?
Yes,
What
sir.
are the factor, how they got disturbed, and how they get changed. So these are the topic you must be knowing. Okay.
Yes,
And
sir.
while explaining about this Murray law, whatever you try to explain, you must have ability to explain this in very brief. You are taking too much time. They will not give you that much time. They will immediately switch to the concept. Okay.
Okay, sir.
And then I ask you about power dissipations, right?
Yeah.
What are the power dissipation and what are the different sources? That was the point of discussion. There I ask you some short circuit power dissipation. If you are not wrong, I asked that
Yes, sir.
sort of one term, okay?
Yeah. How it
And
is
you
happening?
explained partially that it was because of when both the this NMOS and PMOS get on and your VDD get a direct path to ground. Something this you told me,
Yeah.
right?
Yeah.
Now, why this happen? Reason being, whatever input we are applying, fine.
Yeah.
Practically that have some rise time and fall time.
Oh, yes,
Okay,
sir. I forgot this point.
is it clear?
Yes,
So
sir. Yes, sir.
at that time, what you were talking that was a bit irrelevant. So keep in mind, fine.
Due to rise time and fall time.
Okay, because whatever we are considering their instantaneous switching, that one get off, second get on. But actually, my input is not idle. That is a practical input, right?
Yes, sir.
And regarding MOSFET scaling, the ever increasing demand of the electronics appliances has forced to put more and more transistor into the small IC chip.
Hmm.
Everybody want that we can integrate more number of device. Is it clear? And right now
Yes,
you
sir.
just explain me that the number of device doubles almost in 2 year, or you can consider 18 months
18 months.
as per
Yes, sir.
the famous Murray law.
Yeah.
Is it clear?
Yes,
So
sir.
the integration of more devices into the small area has essentially pushed the VLSI process technology to be advanced from micro to.
Sir, voice got mute.
Hello.
Yes, sir.
Into nanoscale level, right?
Huh.
So that is what the reduction of the MOSFET dimension is known as the MOSFET scaling. Okay.
Reduction of the MOSFET diamond. Okay, sir.
Hmm. So there are two type of scaling usually which we do. One is the constant field scaling. Second is the constant voltage scaling. Okay.
Yes, sir.
So that you don't need to go into much detail, but the basic idea you must have, right?
Yes, sir.
Then what are the advantages and disadvantages of the MOSFET scaling? See, MOSFET scaling first advantage is if we are reducing the size, it means more number of transistor can be integrated per chip, right?
Yes, sir.
It means improvement in the speed.
Yeah.
Okay.
More calculation we can perform.
Hmm. Is it clear? And
Yes,
we
sir.
can say improve throughput through the chip. But there are also some disadvantage which occur. You might have studied those short and narrow channel effect, if I'm not wrong.
Yes, sir. This I have not gone through, but I have heard of this term.
At least go through these. There are many short channel effect. Okay, is it
Yes,
clear?
sir. Short channel effects are there.
So these are the point you must be well aware of, right? Rest I'm
Yes, sir.
sharing with your book. At least follow that book from the starting. It will take hardly 3 to 4 hours. I'm not saying just read everything. Just go through that book and collect the point which you think that these are relevant to my interview. Okay.
Yes, sir.
Anything else, Piyush, you want to ask, please?
No,
And
sir.
there one question I asked to draw the waveform. That also I'm sending you through the WhatsApp, right?
Yes, sir. Load current versus time waveform.
Because it is clearly mentioned. Sometimes what happen, whatever they clearly see, they can directly pick a question on that.
Yeah.
It is clearly mentioned that there is some current flowing to the load capacitor. So
Yes,
they can
sir.
ask you simply draw. Can you draw the load current versus time
Anything they
characteristics or
can
not?
ask.
Okay,
Yes,
is
sir.
it clear? So focus on these line, right?
Yes, sir.
I'm sharing you some of the content and name of the book you can download. That is a book basically written in the simple language and only useful data is there, right?
Yes, sir.
Hmm. Okay, good luck, Piyush.
Okay, sir. Thank you. One more thing, sir.
Yeah, please.
Sir, एक तो you told me about that passive components of this PID controller.
Right, right, right.
So as such, as of now, this I have done in algorithm only, so I don't know what is the passive component. That day you asked me about active, so I have done some.
Simply make the use of the R and C combination, na?
So, but how I can implement simultaneously all these things? Yeah, I know that we can make RC as integral and CR as a differential, sir.
Do you know how to design lead lag compensator using RC?
Oh, yeah, got it, sir. Yeah, yes, sir.
Okay,
Yes, sir.
okay.
Yeah.
Mhm. Okay, Pusha.